Part K, 6 basic trig graphs. We're going to go through what the graphs of the functions y equals sine x, cosine x, and all the other things look like. And by the time we're done, we'll be able to add these 6 basic trig graphs to the other 13 basic graphs we looked at earlier, and then start applying transformations to those. These are 6 more graphs you'll have to be able to sketch without a whole lot of thinking. The first one I want to look at is y equals the sine of x. Well, we're just going to plot some points. The sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. Sine of 3 pi over 2 is negative 1. Sine of 2 pi is 0. We can go backwards as well. The sine of negative pi over 2 is negative 1. 0, 1, 0. Connecting the dots, we get our sine curve. Number 2. Y equals the cosine of x. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is 1. Backtracking, I get 0, negative 1, 0, positive 1. And when I go to connect the dots, I get something that looks like this. Number 3. Y equals the tangent of x. Remember that the tangent is the sine over the cosine, so that's how I'll make my table of values over here. The tangent of 0, the sine of 0 divided by the cosine of 0 is 0 divided by 1. That'll just give me 0. The tangent of pi over 2, the sine of pi over 2 is 1. The cosine of pi over 2 is 0, so 1 divided by 0, that's undefined. When I have these undefined values, I'm going to get vertical asymptotes. The tangent of pi is 0. Tangent of 3 pi over 2 is again undefined, so I'll get a vertical asymptote over there. Tangent of 2 pi is 0. Backtracking will continue alternating between vertical asymptotes and points on the x-axis. This isn't really enough for me to be able to graph this thing. I would like a couple other points. Between 0 and pi over 2, I have pi over 4. The tangent of pi over 4 is just 1. So I'm going to get a point over there. If I looked at negative pi over 4, the tangent of that would be negative 1. So I get a point down there. One part of my graph looks something like this. A skinny curve with asymptotes at negative pi over 2 and pi over 2. I'm going to continue the same pattern between all pairs of asymptotes. My graph will look something like this for the tangent of x. Jumping down to number 6, I'll do 4 and 5 in a moment. If we want to look at y equals the cotangent of x, well, I'm going to do something similar, realizing that I'm plugging into the cosine of x over the sine of x. The cotangent of 0 is 1 divided by 0. That's undefined, so this time my vertical asymptote is right on the y-axis. Cotangent of pi over 2 is 0. Cotangent of pi is undefined. Cotangent of 3 pi over 2 is 0. And 2 pi is undefined. 0, undefined. 0, undefined. Plugging in additional points, the cotangent of pi over 4 will be positive 1. The cotangent of 3 pi over 4 will be negative 1. So one branch of this function will look like this. That pattern will continue again between every pair of asymptotes. And my graph of y equals the cotangent of x looks like this. Number 4. The cosecant of x. Y equals the cosecant of x. Well, this is just the same as y equals 1 over the sine of x. What I'm going to do here is I'm going to start by just sketching the sine of x. Then I'm going to use reciprocal ideas to figure out what my cosecant is going to look like. I'm going to start this one by sketching y equals the sine of x. I already know what that one looks like, so I'm going to get something like this. And backtracking, I get something over here as well. If I now want to sketch y equals the cosecant of x, I need to do the reciprocals of the points that I had on my sine function. Here I have 0. The reciprocal of 0, 1 over 0, well, that's undefined. So I'm going to get an asymptote on my y-axis. The y value here was 1. The reciprocal of that is still 1. Reciprocal of 0 gives me an asymptote. Reciprocal of -1 is -1. I'm going to continue alternating between these good values and asymptotes. So I have -1 there, asymptote there, +1 at -3 pi over 2, and asymptote at -2 pi. Next, if I was to do the sine of pi over 6 and get 1/2, the reciprocal would give me 2. So I'm going to have a point over here. Same deal with 5 pi over 6. The reciprocal of 1/2 would give me 2. I'm going to get a little curve that looks like this. And I'm going to continue doing shapes like this in all my regions. I'm going to get a curve like this, and over here, and over here. And this black graph is the graph of y equals the cosecant of x. I think it would be fine if instead of memorizing this, you remember how to create it from your sine graph. And if you were to start by graphing a sine and then doing the reciprocals, I think that would be just fine. Number 5, y equals the secant of x. And remember, the secant of x is just 1 over the cosine of x. I'm going to start this one just like the last one, but instead of sketching the sine of x, I'll start by sketching y equals the cosine of x. And I have a graph that looks like that. Now to do my reciprocals, I get 1 there, vertical asymptote at pi over 2, -1, vertical asymptote, +1. Going back, I get a vertical asymptote, -1, vertical asymptote, +1. Connecting dots. Not really connecting the dots, rather drawing in the curves. Sorry about that. Secant of x will look something like this. Again, if you can just create it by using your cosine function, that'll be just fine.